Yes, my name is Nonkululeko Madondo, and I am having you here for Physical Sciences Grade 11. I hope that everybody has been having a great day, and we've been doing all the work and the homework that we said you guys had to do. And I hope that most of you will be joining in. It's quite quiet in this group. It would be nice to have some more active um, activity and people asking questions, people, finding out what is going on with certain problems. But nonetheless, I'm here for you, and I hope that whatever I'm teaching you, you're actually understanding. Don't forget to also invite your friends. They can also come and join in this conversation here on our Zoom meetings. That's where you can be able to participate. But later on, if you want to check it again, you can always get it on YouTube and Facebook. It's live on the Africa Teen Gigs Online School. But to be able to participate, it can happen on Zoom. So thank you guys, and I am your presenter, Nonkululeko Matondo, and today's topic, we're going to be dealing with stoichiometric calculations. Well, I don't know if you guys have done the homework yesterday, but I see some of you guys haven't appeared yet, so I'm a bit worried about um, some of my students that are usually in the group. But I hope that most of you are on YouTube checking out this lesson. But nonetheless, we continue. Another thing I wanted to get onto today, we're going to be doing our Unit 4. Unit 4, remember, guys, we are using the Oxford Successful Textbook. That's the one that I used to teach. So you guys can also get it. I also got it for free on Snaplify. Snaplify is a program that is there for us young people. It's there. All the textbooks are there. There's about hundred and hundreds of textbooks that you can find there. So if you are having trouble with anything textbook wise, you can go on Snaplify. There's also Siavula. That's also a good textbook. That one you can even download on Google. So let's get onto it. I just want to go back. I remember yesterday I promised you guys that we'd be getting ourselves the homework that we did in the previous day. Yes, let me just open it on my phone. The questions. I think you guys were supposed to do activity one on unit three. Yes, on unit three, on unit two, you're supposed to do number four and number five, but we couldn't do it yesterday because I couldn't log onto them with my computer. So today I've got them here, and I think that we can just discuss them. In that problem on number four, they talk about in 100 gram, there is 31 grams of potassium and 29 gram of chlorine and 39.2 gram of oxygen. So basically what they're looking for is is the percentages of each. They're looking for the empirical formula. So if you check here what I did, at first of all, I looked for the number of moles of each of them. I looked for the number of moles for each of them. You can see there for potassium is 31.8 divided by 39.1. So remember, with the molar mass, you just take it from your periodic table. Make sure that when you're working with chemistry, you always have your your periodic table with you. So there you can see for potassium it's 39.10, and that's what it gave me. And I did it for chlorine, and I also did it for oxygen. And then after that, what I did was I tabled them so that I can be able to get the ratios. I tabled them so that I can get the ratio because here they want us to calculate the empirical formula. So I put them on the table, and what you do after this, you divide them with the lowest one, with the lowest one. And then when you divide it with the lowest one, you get a ratio, and you always take the ratio to the nearest 10. For example, if it's going to give you 0.9, then you know you'll just make it a 1. And then this one is a 3. So this is what we got for our empirical formula. So our empirical formula, basically, we're looking for the sub numerals of all our elements. So here we can see K is a 1, Cl is a 1, and O is a 3. So this is our formula. So this is what we get for number 4 in activity 1. And then we also did number 6. Okay, on number 6, a sample of 10 gram of a liquid is analyzed, and it established that the sample consists of 9.23 carbon and 0.77 gram hydrogen. The molar mass of the substance is 78 gram, and determine the molecular formula of the substance. Okay, what does this mean? First of all, as usual, we're going to start looking for the moles first. When you look at the moles, it's going to be 9.23, like what is given there, divided by the molar mass, which is 12.01. This you get from the periodic table, and this will be your answer. And this one again, you do it also for hydrogen, but here I just forgot to write the mole, but it has to say mole. Remember, guys, you always have to put in the standards, the standard units, because otherwise you might get your answer wrong because they don't know it's 0.72 watt. So you must always write more. So, and then I continued from there. I did that table again where I divide them by the lowest number of moles. So it's going to be 0.762. So this one, the empirical one, you get CH because it's both 1 and 1. So it's going to be CH. Guys, before you get the molecular formula, you always have to start getting the empirical one first. So we move on. On the empirical formula, okay, you're going to say, we're going to do the molar masses now. The molar mass, we're going to say 12 plus 0.1 because now we're working with the empirical formula. So this will be the empirical formula as we stated. And then after that, we're going to calculate the total ratio for this. So what we're going to do, because in our question, we were already given the molar mass of the substance. So how you get the formula, the molecular formula, you're going to say the molar mass of the substance divided by the empirical molar mass, which is this one that we calculated here. You divide it and it gives you a 6. You always go to the nearest 10. And then after that, if it's a 6, because this was 1 and this was 1, it's just going to be molecular formula is going to be C6 and H6. I hope that everybody understand. Guys, if you do not understand what is going on, please send me a chat if you are here in our classroom and give me a shout out, and I'll go back and I'll explain whatever it is that you do not understand. So that was that homework of day before, the number 4 and 6, and I hope that you guys understood it. And then after that, I'm going to go to yesterday's homework. Remember yesterday I gave you guys homework. I hope that everybody has done it. If you have encountered problems as we go through this, you can just drop me a chat and let me know. I said we should do the even numbers only, né? And let me just go to it on my side too. The first one, this one, number 2. Number 2 was a true and false question. So I just want to see the problem. Okay, yes. Molar mass, molar volume, atomic. Okay, that's number 1. Okay, state whether the following statements are true or false. And if false, write down the correct statement. Then it says 1 mole of ammonia gas and 1 mole of oxygen gas both have the same number of atoms at room temperature. So this one is true because it says 1 mole of any gas at STP occupies the same volume. So at STP, it's already temperature. You understand? So that's why that one is true. And then on 2.2, they say 1 mole of water in the gas phase occupies a volume of 22.4 dm cubed at standard temperature and pressure. This one is very true, and you can check it out by actually doing the the problem and say volume is equals to number of moles times the volume of STP, which is 22.4, and that would give us a 22.4. So it is true. And then number 2.3 says that 12 grams of carbon occupy a volume of 268.8 dm cubed at STP. That again is true because you can just substitute the formula and say N times Vm. This will give you 12 times 22.4. This will give you that answer. So all our answers there are true. And then we go to number 4. Okay. In number 4, what they ask us is calculate the volume of 50 gram of nitrogen gas at STP, standard temperature and pressure. What does that mean? Okay, it means that we already have the volume for the standard temperature and pressure, which is 22.4. You can always write it down if you want to write the given. So what we do first, we know that, remember I told you guys yesterday, whenever you hear nitrogen gas or oxygen gas, it means that it's got a 2. It's N2O2. And yes, so whenever you hear them say hydrogen gas, oxygen gas, or nitrogen gas, then you know it's already an N2 at STP. So this is how we calculated it. We looked for the molar mass of N2, which is going to be 14.007 times 2, and this will give you the 25.014 grams per mole. Don't forget the standards ever. And then from there, we look for the number of moles. It's going to be mass divided by molar mass. This will be 50 divided by 28.2, supposed to be 25.014. I hope I didn't do it wrong in the calculation. 25.01, 50 divided by 20. Oh no, it is 28. I think the 25 there, it's probably because of the scanning, so the line doesn't really show, because it should be around 28. So that will give us 1.785. Guys, just check there. This one here, there's actually a line here that shows that it's an 8. It's just that this was scanned. So you know the scan always makes things lighter. And then from there, now we can calculate the volume. So you see, they want the volume, but there's certain things that you have to find before you get to the volume. You have to find the number of moles. And to find the number of moles, because they're not given, it means you need to find the molar mass in order to satisfy the equation of the number of moles. So this was our answer. But I see on the book they got, I think, 40.1. That could be due to, for example, you see the decimal places, these places, all of this, they play a role in the final answer. So because they hadn't stated exactly how many decimal places we should take, it gives us a rough number, but it's not far-fetched because it's just about a 1% percentage error. So it's not bad. So this is how you do it. And now we're going to move to number 6. Okay. Number 6, they say carbon disulfide combusts in oxygen according to the following unbalanced equation. If you're looking at the problem, the unbalanced equation is CS2 plus O2 gives you CO2 plus SO2. So whenever you solve a question where you are given an equation of this matter, first thing you do is you make sure that it's balanced. So if you can see here, I've balanced it out. I've added this 3 on the equation, and I've added this 2 also on the equation. Reason being, you see here, we've got O2 and an S, but there we've got S2. So already there needs to be a 2 there. So the O there, there's O2, and then we've got carbon dioxide. So now that means we've got 4 oxygens over here and 2 over there, which makes it 6. So which means here on the oxygen O2, we're going to have to put on a 3 to balance it out and make it 6. So now this equation is balanced. And now we can continue. Now we can listen to what the problem actually says. Number one, they say, calculate the volume of oxygen used. Okay. Then we go down to the number of oxygen used. Okay. If 3 dm cubed. Remember what we said when we were doing the lesson yesterday is that one will be given. One, if you are given a volume, then you can be able to calculate the rest. They could have given you pressure or whatever, or number of moles, but they gave you the volume. But when you have one, you can get the other one. That's how the standard temperature and pressure works. They are both equal at this at STP. So we go to V1. V1 over N1 is equals to V2 over N2. And then the N in this case is the number of moles, guys. Remember we mentioned that these numbers here in the front, this one should be a 1 because there's nothing. This one it's 2 because it's written 2 there. Those are the number of moles. So which means we've got 1 mole of CS2, we've got 3 moles of O2, we've got 1 mole of carbon dioxide, and we've got 2 moles of SO2. So now, when we do these equations, remember, we always have to have 3 knowns and 1 unknown. In this case, they gave us the volume of CS2. So which means that CS2 is the one that we're going to always equate to what we are looking for. So it's going to be 3 dm cubed. We're writing it here, and then we check what's the number of moles for CS2. Here, there's no number in front of it, so it's a 1. And then that'll be equals to, because we're looking for the O2. Yes, I think we are looking for the O2. The number of moles is going to be 3. So now we can look for V2. So what is V2 going to be? V2 will be equals to 9 dm cubed. Okay. Number 6.2, this one was a bit tricky, but I did them both because the question is a bit tricky, but it seems like it falls more on the SO2 side. But I just did them all. Then here we do the same thing because we've got this one, which is a given. We're going to say V1 over N1. It's going to be 3 divided by 1 because there's only 1, and then equals to SO2 divided by 2. Then we can find the volume there. So the volume is going to be V2 is equals to 6 dm cubed. I hope that you guys understand what is going on there. And if you don't, drop me a question and ask wherever you're feeling a bit lost. You can also get me on my LinkedIn as Chio Madondo. If you guys have problems that you want to know, you can just send me an inbox there. Okay, then we are going to continue. We're going to continue with what we had planned for today. So today we are doing unit 4, stoichiometric calculations. What we're going to do today, we're going to learn about the mass and volume ratios in chemical reactions. Number 2, we're going to look at the reactants in excess. And number 3, we're going to be doing calculating mass, volume, or number of particles. And you know me, guys, I always prefer going straight to the textbook so that you guys can read through and I can just explain things that you guys do not understand. Because you know, when you know the theory, you know the work. And you know what's so nice? Everything that we've been doing from Monday, it keeps building up. It's building up. It's just adding more equations, adding more problems. But more or less, we are just doing the same thing. And you get used to it by practice. I hope you guys do all the homework and you getting to understand everything that we're doing here. So now I'm going to go straight to our textbook and we're going to see. Oh, okay, I'm already too far. Okay, so I'll continue for now. Stoichiometric calculations with mass, volume, and number of particles. Remember what particles is. Particles can be atoms or molecules, etc. So that's what it means by number of particles. So it says when chemists in the pharmaceutical industry develop medicine, they need to know how much product will be made from certain amount of reactants. You guys do understand that, right? Like for example, when they buy their raw materials, they need to know that maybe 5 kg of zinc and 2 kg of magnesium. How much of that product are you going to get from it? So that's basically what they mean. And then a chemical reaction can be represented by a balanced chemical equation, and the balanced equation tells us the mole ratio of the product and the reactants. I hope you guys get what that means. So let's continue. The mass and volume ratios, the mass and volume ratios in chemical reactions. Over the years, the results of chemical reactions have been found experimentally. We have measured how much each chemical reacts and how much each product is formed. Okay, guys, I'm just looking for the page quickly on my side. I don't know if I'm too forward or too far back. No, 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 no. This one we've done it. Okay. So you see, all of these things, they go back to what we've already done in our previous lesson. It's just adding on. So that's basically what happens. So now we're moving on. Molar volume and gases. Okay, this is what we did yesterday and the homework that we had. Yes, here we are. So mass and volume ratios in chemical reactions. Over the years, the results of chemical reactions have been found experimentally. We have measured how much each chemical reacts and how much each product is formed. That's what happens basically when we're balancing out equations. We're trying to make sure that they're in a balanced state, but at the same time, we get to know how much of each is needed to balance out the equation. Okay, we use ratios to determine the amount of each reactant that we need to produce a specific amount of product. Remember, that's the number of moles, like I showed you before, that you find a number in the front. That actually shows how much quantity is needed for that certain reactant or product. Okay, reactants in excess. Okay, that's a new thing that we haven't dealt with. The reactants in excess. We often use an excess of reactants. There is more than needed to complete the reaction. So some reactants will be left at the end of the reaction. The excess reactants is therefore not included in ratios of the stoichiometric calculations. Okay, excess is amount that is more than necessary. So calculating the mass, volume, and number of particles. Okay, we're going to do some problems with that regards. If you guys have problems, just let me know and I'll go back slower, or I'll just take on where you guys are feeling a bit lost. Okay. Often the mass, volume, and number of particles of one substance in a reaction and need to calculate the mass, volume, and number of particles of another substance in the reaction. To do this, so this is how it's done. First of all, you write your balanced equation, and then number two, you convert all given masses, volume, and number of particles to the number of moles. So basically, if they have given you something in grams, what are you going to do? You're going to take it, you're going to use that formula. N is equals to mass divided by molar mass, and then you're going to look for the number of moles. So basically in this one, we're always working with the number of moles. Whatever you get, whether it's volume also has an equation where you can end up getting the number of moles. That's the equation that you will take. So which means first step, you get an equation and you balance it. After balancing it, you change whatever is given into the number of moles. Number three, use the stoichiometric ratio in the balanced equation to determine the number of moles of the unknown. Does that ring a bell? That's something like we did in yesterday's homework. Remember, what we did there, we took the ratios and we divided it from, for example, if you have the number of moles, or you have volume, we said volume over number of moles equals to volume over the number of moles. So what you do in each, you you can do that for all your problems. You always have to make sure. That's why it's so important to balance your equation. If your equation is wrongly balanced, you will get 0 out of 10 marks, because everything else follows that balanced equation. So after that, you convert the amount of the substance, number of moles, to mass, volume, or number of particles. So you know what they mean there, because I know that sometimes, as much as you've converted it from masses before, but the first mass that you converted it to, remember that one was one of the reactants mass that was given, not all of it. But now they're looking for the mass, volume, or number of particles of the product that you get. So make sure that you don't take the same gram and put it on the end of the calculation in step 4. It's two different things. In the first one, you're working with the reactant. They give you something in the reactant part. And what they're looking for is the number of mass, moles, or volume in the product part. So the masses will be different and the moles will be different. So be aware of that. Okay, then let's go and look at an example. Okay, there we have it. They say mass, volume, or number of particles of known. Calculate the number of moles. Step 2. Use mole ratios to determine moles of unknown. Remember what I said. Moles ratio is the one way you're going to take. These are the mole ratios. You see these ones. I just can't highlight it properly here. Okay, this one doesn't want to highlight, but this one, for example, this is a ratio. This 2, this is 1, this is 1, this is 1. So they say use mole ratios to determine the mole of the unknown. So whatever you're given, it's going to be x1 over ratio. If, for example, it's HCl, it will be 2 is equals to x2 over the ratio. If, for example, you're looking for ZnCl, it will be 1. Do you guys understand what I'm saying? I hope you're understanding, because in that case, I'm saying X because it could be volume that is given, it could be mass that is given, or it could be number of particles, So that's why I just rounded off as X. Okay, calculate mass, volume, and number of particles of the unknown. Like I said, usually they'll give you something here on the Zn, and what they're looking for is the mass of something else. For example, this one here, they said calculate the mass of HCl. So here they're looking for this mass, and they're also looking for the volume of this one. So it's not going to be the same thing that they're going to ask you from the given. So when you come here, you cannot use the same mass. Okay, and then let's start this problem. It says 8 grams of zinc reacts completely with an excess of hydrochloric acid at STP to form hydrogen gas. Calculate the mass of HCl that reacts and the volume of hydrogen gas that is produced. So first of all, this is our equation. Okay, they've managed to balance it by putting a 2 here in front because of the Cl that is 2 and the H2 that is and the H2. So they've had to put 2 here. So what we do, convert anything that's given into moles. So here, what are we given? We are given 8 grams of zinc. So we're going to use 8 divided by the molar mass, and this is what it's going to give us the number of moles. Okay, and then after that, from the balanced equation, now that part that I told you guys, 1 over x1 is equals to 1 over x2, and x2 in this case is going to be 0.122, yeah? And then it's going to be 0.122, and this is going to be H2, the NH2, and this is what the answer is going to give us. I hope you guys understand how we got it. But we will be doing another problem later on, just before the class ends. Okay. And then this one is for HCl and the number of mole in zinc. Once again, it's going to be, for example, ratio over x1 is equals to ratio over x2. And then this one is going to be 2, so it's going to be 2 times 0.122. And then this one is going to be HClN. And this is going to give us 0.244. We're going to need them both. Remember, H2 is what is asked of volume, and HCl is what is asked for calculating mass. So step 4, now we're going to look for the mass. This is going to give us number of moles times 36.46. How did we get 36.46? We check on the periodic table. Hydrogen is 1,008 and Cl is 35.453. You add them together, you don't multiply, you add them, and then they will give you the molar mass of HCl. And this is your 8.9 gram of HCl reacts. Okay. And then now we convert the amount of substance to volume. So they ask that for the hydrogen gas. So here what we say, it's a different formula. We're going to use the the STP volume, and that's going to be N times Vm. So it's going to be 0.122 times 22.4, and this is what is going to give you in dm cubed hydrogen gas is produced at STP. I hope you guys understand this example. I know if you're not sure what's happening, it's kind of difficult for you to think like how they got some of these answers, especially this part here. But we're gonna get back to it because I do have a problem that I think will make things easier for you guys that we'll do later on. I hope that everybody is still with me on. Oh, okay, these are the experiments. Ash, I'm not sure if you're going to be doing experiments because we don't have experiments. So this part you guys can read through it on your own, and hopefully there'll be times where we get to do experiments. But for now, we do not have the equipment. One thing that you guys must know is that in experiments always have to be done in a lab, and it's because all these elements and chemicals are so dangerous. You can't just do it in your house or anywhere that's unsafe, and you always have to wear protective clothes. So please don't try these experiments at home. Okay, so we get to activity 2. Okay, these are some of the problems that we're going to do, but for now there's one problem that I want us to do. I want us to, they say in number 1, calculate the mass of magnesium oxide that is produced from 16 gram of magnesium in the reaction between magnesium and oxygen. The unbalanced reaction is MgS, S stands for solid, plus O2 gas gives you MgO solid. Okay, so what they want here, they are looking for the mass. So what needs to happen here? First of all, what we're going to do is balance the equation. So let me just go through it, one that is done already. Okay, this is a problem that we did. Okay, activity 1. Okay, they've given us 16 gram of magnesium. They're looking for the mass and of MgO. So this is the equation when it's balanced from what I showed you guys. Remember, it didn't have these 2's. These 2's were not there. This 2 was not there. They just gave us MgO, and they also gave us just Mg. So first things first, we have had to balance the equation. This is always your first step. Do not forget that. And then after that, convert it to the number of moles. Okay, so we're going to say number of moles for magnesium is going to be M divided by molar mass, and that's going to be 16 divided by 24.305, and it gives us 0.658 mole. Okay, we always work with the given first because you can't work with information that you do not have. So because mg is what is given, this is what is going to lead us to answers of the unknown. Okay, and then from the balanced equation, which is this one, these are the number of moles, this is the number of moles, and this is the number of moles. So it's 2, 1, 2, basically. Yes. So from balanced equation, I just wrote it in ratios so that you guys can be able to understand how we got to it, because I know there's people that usually have a tough time figuring out. So you say from balanced equation, MGO, okay, N1 divided by ratio 1 is equals to N2 over ratio 2. Because Mg has the given and we've got the number of moles, that will be N1. And then MGO will be N2 because we don't know what's the number of moles, but we do have the ratios. So N1 divided by N2 is equals to N2 divided by ratio 2. And this will give us 0.658 divided by 2 because you've got 2 there for magnesium, and N2 over 2 again because MgO has 2 number of moles. And then this will be our answer. So the number of moles is once again 0.658. My apologies for not writing the mole, but I hope that you guys understand what is going on there, because it's very important, especially this part of ratios. If you don't understand it, you're going to have a lot of problems because you will be doing the wrong thing. If you do not get it, just drop me a chat and I'll reiterate it for you. Okay. After that, then we need to find the mass of MgO. But before we do that, okay, we wrote down the formula, which is N times M. Okay, but we do not have M. We do not have M. So what has to be done now? We need to find the M. So the M, which is the molar mass of MgO, magnesium oxide, is going to be 24.305 plus 15.999. Well, other people tend to just take it as 16 because it just depends on which periodic table of elements you have. But if you're using the one that I'm using, it says 15.999. So I just took it like that because I do not want to confuse anybody. So this will give us 40.305. Oh, I forgot to write gram per mole. And then from there, you take that problem and you put it back in the equation. So it's going to be 0.658 times 40.305, and that will give us an answer of 26.52 gram. I hope that you guys understand it. If you don't, tell me where you're getting lost, and I will help you. So let's go back to the problem now. So yes, the answers are more or less the same. If you check from the solutions, it's 26.6, but we know it's because of all the decimal places, using different decimal places, that also has an effect on the answers that you get. Okay, and then the next one, let's go to number 2. Number 2 says calculate the volume of oxygen at STP, standard temperature and pressure, that reacts with 15 gram of magnesium in question 1. So this is almost like a continuation of question 1. So it would be more like, for example, this was 1.1 and this is 1.2. This is very similar to the example that we did just before this. Okay. So let me go back to that problem and see how we get. They want the volume now of oxygen. Before they wanted the mass of magnesium oxide. Now they want the volume of oxygen. So let me just go to that problem. Okay. Okay. So now we're doing the number 2. The number 2, then we go, it's going to be from the balanced equation, O2, we're going to, because we're working from a continuation of a problem. Gosh, the screen is too small. Let me just try and minimize the screen, maybe to 75. Yes, this is so much better. Okay, yes. You see what's happening here? From the balanced equation, now we're going to be working with O2. But do remember, don't now go and use mg to calculate the ratio for O2, because if your mg is wrong, then this problem will also be wrong. So what do? We go to the first given one. We're going to use the magnesium ratios and balance it against the oxygen, because we don't want to use these ones that we calculated just in case they're incorrect. You will have a problem. So it's going to be N1 over ratio 1 divided by N2 over ratio 2. This will be 0.658 divided by 2. Then it will be N2 divided by 1. Then N2 will be equals to 0.329. So now we go to the volume equation. The volume equation, it's going to be the volume of oxygen is equals to N times by Vm. Vm is standard, it's the Avogadro constant. And that will be 0.329 times 22.4, and that will give us 7.37 dm cubed at STP. I hope you guys are following. I hope it's easier to understand when I write it as N1 over ratios. These ratios, it's always these numbers here in the front of your element or compounds. So I hope that you guys are understanding this and you can do some of the activity problems, because our time is almost up. So let me see which ones we can do maybe for tomorrow, because let me see. Let's do number 3, number 5, and number 7. 3, 5, and 7. And we can do them tomorrow when we start our program. Let me see, there's no other problem this side, no? Yes. So let's do these 3 problems and see if we can do them. Tomorrow's lesson, then I'll be able to go through it once again. Just to remind you that tomorrow we're going to be starting with Unit 5, experimental yield. I'm not so sure too much about this, but if it has also a lot of experiments, then we're going to move forward. We are moving forward, guys, and I hope that we are all in line with what is happening in physical science. Physical science, especially chemistry, is a beautiful, beautiful chapter, section of physical sciences. And I hope that you guys are really enjoying it and understanding it at the same time, because it's really not difficult. It just needs a lot of practice. It's like math. It's all about practice, practice, practice makes perfect. And you can see from Unit 1, we've been coming along with the formulas. In each unit, they just add formulas, but they all work together and they all coming through. Up until now, we've been adding formulas into our equations. And I hope that you guys have been following that pattern and will be following it. I thank you guys so much for this lesson. I am Nonkululeko Matondo. Please catch me again tomorrow here at 12 o'clock. Invite your friends, invite your family. Anybody is welcome to come and join us here on the Africa Teen Gigs online school to learn. And please, guys, don't be afraid to participate. Oh, I see there's some chats that are in here that I did not see. Ma'am, can you please repeat step 2 and 3? Okay, let me try and do it quickly. Let me try and check it. Step 2 and 3. Okay. I'm not sure. Let me just can you please unmute yourself, so that you can let me know which part?
Dania,
Yes, yes, dear.
I have unmuted her, but she's muted herself again.
Oh, because I don't know. Do you understand now? If you understand, just show me a wave and then I'll know that you understand. Hello.
She's
Okay. Thank you so much, Dinero. Oh, guys, thank you guys so much. Our time is so up, and thank you for a great teamwork. And tomorrow, let's do those problems and come back with to and do the answers. And please do your homework. And tomorrow we'll continue again with the next chapter. And thank you guys so much. From me, Nonkulego Matondo, I'm signing out. Thank you and goodbye.